The drug causes the addiction. This was not speculation. It was considered proven by science, by data, by hundreds of peer-reviewed experiments conducted in laboratories across the United States and Europe. The evidence came from rats, isolated rats, placed alone in small metal cages, given access to two water dispensers, one containing plain water, one containing heroin or morphine, chose the drug water repeatedly, compulsively, sometimes to the exclusion of food, sometimes until they died. The conclusion was direct. These drugs are irresistibly addicting, even to rodents, and if to rodents, then by extension, to humans. This conclusion shaped the war on drugs. It shaped criminal sentencing. It shaped how hospitals treated patients and how governments allocated billions of dollars in public funds. In 1978, a psychologist at Simon Fraser University in British Columbia looked at those experiments and asked a question that, in retrospect, seems obvious. What if it wasn't the drug? What if it was the cage? To understand what Bruce Alexander was challenging, you need to understand the conditions of the experiments he was challenging. Standard laboratory rats in the 1950s, 60s, and 70s lived in individual metal cages. Although housed in proximity to one another, the sides of the cages were solid sheet metal. The rats could not see each other, touch each other, or interact in any way. Their entire existence consisted of the cage, a food dispenser, a water dispenser, and the occasional appearance of a researcher to clean the metal pan beneath them. For drug experiments, rats were placed in Skinner boxes, smaller enclosures containing a lever that, when pressed, delivered a drug directly via an intravenous catheter, or a fluid dispenser offering drug-laced water. Under these conditions, rats self-administered heroin, morphine, cocaine, and amphetamines in large quantities. In some experiments, they pressed the lever hundreds of times per session. In some experiments, they stopped eating. In some experiments, they died. By the end of the 1970s, hundreds of such experiments had produced consistent results across rats, mice, monkeys, and other captive mammals. The scientific consensus was that these results proved something fundamental about the pharmacology of these drugs, that they were capable of overriding survival instincts and taking control of behavior. He thought it might be measuring the desperation of the cage. In 1976, Alexander and his colleagues at the Simon Fraser University Drug Addiction Research Laboratory began constructing what they called Rat Park. The specifications were published in their peer-reviewed papers. Rat Park was a large open-topped plywood enclosure with 8.8 square meters of floor space, approximately 95 square feet. That is 200 times the floor area of a standard individual laboratory cage. The floor was covered in cedar shavings. The enclosure contained empty canisters and small boxes for hiding and nesting. There was a 2.3-foot climbing pole. There were 16 to 20 rats of both sexes living together. The rats in Rat Park could eat, play, fight, mate, and interact socially, behaviors that rats engage in naturally and that are entirely impossible in an individual metal cage. Attached to the wall of the enclosure was a short transparent tunnel, just wide enough for one rat at a time. At the end of the tunnel were two fluid dispensers, one containing plain tap water, one containing a morphine solution sweetened with sugar to reduce aversion to the taste. Both groups, the rats in Rat Park and a control group in standard individual cages, had access to the identical choice, the same drug, the same concentration, the same sweetener. The only variable was the environment. The results of Alexander's first experiment, published in the journal Psychopharmacology in 1978, showed that rats living in Rat Park consumed significantly less morphine solution than rats in individual cages. In some experimental conditions, the difference was not marginal. Alexander later stated that under certain conditions, isolated rats consumed nearly 20 times as much morphine as the rats in Rat Park. Alexander then designed what he called the seduction experiment. He wanted to eliminate the objection that Rat Park rats simply preferred to avoid the drug, so he forced both groups to consume morphine for 57 days, long enough to guarantee physical dependence and withdrawal symptoms in all subjects. After 57 days, both groups were given the free choice between plain water and morphine solution. The isolated rats continued to choose the morphine solution. The Rat Park rats largely switched to plain water, even though they were physically dependent, even though they would experience withdrawal. This was the finding that Alexander believed proved his hypothesis. Physical dependence alone was not sufficient to sustain addiction. The environment determined whether dependence translated into compulsive use. However, the story does not end there cleanly, and Alexander himself has documented this. Both Science and Nature, the two most prestigious scientific journals in the world, rejected the original 1978 paper. It was eventually published in Pharmacology, Biochemistry, and Behavior. Follow-up experiments produced mixed results. A replication study found that both caged and Rat Park rats showed decreased preference for morphine compared to Alexander's original results, and the author suggested a genetic explanation for the differences. Other studies found that while social isolation influences heroin consumption, isolation is not a necessary condition for drugs to be reinforcing. Funding for Rat Park was canceled. The experiment effectively ended. In 1971, two United States congressmen, Robert Steele of Connecticut and Morgan Murphy of Illinois, returned from a visit to American troops stationed in Vietnam with a report that alarmed the Nixon administration. Approximately 15% of U.S. soldiers in Vietnam were addicted to heroin. Follow-up research revised that figure upward. By some estimates, 35% of service members had tried heroin while in Vietnam, and 20% had become addicted. The heroin available in Vietnam was of extremely high purity and extremely low cost. It was smoked, snorted, or injected. It was everywhere, and the soldiers using it were not, by the clinical profile of the time, considered typical addicts. They were men of varied backgrounds, varied personalities, varied prior drug histories, most with minimal previous drug experience. President Nixon created the Special Action Office of Drug Abuse Prevention and commissioned a formal study. Sociologist Lee N. Robbins of Washington University School of Medicine was hired to lead it. In September 1971, every soldier scheduled to return home was given a mandatory urine test. Those who tested positive were required to undergo detoxification before departure. A random sample of 470 returning soldiers was selected for intensive follow-up interviews, alongside a sample of 495 who had tested positive for opioids. 8 to 12 months after the soldiers returned to the United States, Robbins and her team conducted confidential interviews and requested urine samples. The results were so different from what was expected that, as Robbins later wrote, presenting them felt uncomfortable. Among soldiers who had been addicted to heroin in Vietnam, only 5% had relapsed to addiction in the first year after returning home. Robbins and her team followed up again 3 years later. The relapse rate had risen, but only to 12%. In scientific terms, the addiction rate among soldiers in Vietnam had risen from 0.4% prior to arrival to 20% during service. After returning home, it dropped to 1% within 8 to 12 months, without treatment, without rehabilitation programs, in most cases without any formal intervention at all. What had changed was the environment. Vietnam was a war zone. Heroin was available on every corner. The men were far from home, in danger, with limited agency over their circumstances. Home was not a war zone. The same heroin was not available on every corner. The men had families, jobs, social networks, and futures to return to. Same people, same drug history, same neurological dependence. Different environment, radically different outcome. The findings from Rat Park and from Lee Robbins' Vietnam study are frequently cited together as definitive proof that addiction is a product of environment, not chemistry. The reality is more precise and more complicated. The Vietnam data is robust. It has been replicated in follow-up analyses and is not seriously disputed within the research literature. The environmental shift from Vietnam to home was accompanied by a dramatic and largely spontaneous reduction in heroin addiction. The Rat Park data is more contested. Replication attempts produced inconsistent results. One study found that both caged and park rats showed decreased morphine preference compared to Alexander's original study. Other research established that social isolation influences but is not a necessary condition for addictive behavior. Alexander himself acknowledged complications in his own published work. In the 1981 paper, he noted that the Rat Park housing effect was not confirmed under certain experimental conditions using a tasteless narcotic called etonidazine, nor in two subsequent morphine experiments. The scientific picture that emerges from all of this research is not that drugs cannot cause addiction. They demonstrably can, and the neurological mechanisms are well documented. The picture that emerges is that the drug alone is not a sufficient explanation. Environment modifies the probability, the severity, and the persistence of addiction in ways that the original isolated rat experiments completely failed to capture, because those experiments themselves were conducted inside one of the most extreme environmental conditions possible. A rat in a metal cage, in solitary confinement with nothing to do, is not a normal rat, and the behavior of a rat in those conditions tells us something about what happens to mammals under conditions of extreme deprivation. What Alexander argued is that the original experiments had been measuring deprivation, not addiction, and that the policy built on those experiments was built on a flawed premise. Alexander's first paper was submitted to Science in 1978. Science rejected it. It was submitted to Nature. Nature rejected it. It was eventually accepted by Psychopharmacology, a specialist journal, and published with what Alexander described as little response from the wider research community. The funding for Rat Park was canceled. The physical enclosure was dismantled. The experiment stopped. Alexander continued to write and present on the topic, but within the mainstream addiction research field, the work was largely set aside for approximately 30 years. The reasons for this reception are not fully established. Alexander has speculated that the findings were threatening to a research community that had spent decades building a body of work on the assumption that the drug itself was the primary variable. Others have pointed to the legitimate methodological concerns, the small sample sizes, the inconsistent replications, the specific conditions under which the housing effect did and did not appear. What is documented is that around 2008, the research was rediscovered, widely shared, and began to influence public conversations about addiction policy in ways that the original publication never had. That rediscovery coincided with a period in which the opioid crisis in the United States was producing addiction rates and patterns that were difficult to explain through a purely pharmacological model alone. What Rat Park established, even accounting for its limitations, is that the environment in which an organism encounters a drug is a significant variable in determining whether exposure becomes addiction. This has now been documented in multiple ways, across multiple methodologies, in animal and human populations. Hospital patients regularly receive powerful opioids for pain management, often for extended periods. The rate at which this produces ongoing addiction in patients who return to normal life is substantially lower than the rate observed in populations experiencing chronic social disruption, economic instability, or trauma. This does not mean drugs are harmless. Heroin is physically addictive. The neurological mechanisms of dependence are real and well documented. What it means is that dependence and addiction are not the same thing, and the conditions under which dependence becomes the compulsive, life-consuming behavior pattern that defines addiction appear to be significantly mediated by the quality of the environment the person, or the rat, is living in. Alexander summarized his position in Senate testimony in Canada. The intense appetite of isolated experimental animals for heroin in self-injection experiments tells us nothing about the responsiveness of normal animals and people to these drugs. Normal people can ignore heroin even when it is plentiful in their environment. Lee Robbins drew a parallel conclusion from the Vietnam data. The soldiers who recovered were not exceptional people with exceptional willpower. They were ordinary men who returned to environments that gave them reasons not to use. The policy implication, which remains contested, is that a framework focused primarily on the pharmacology of the drug and the criminality of the user may be addressing the symptom rather than the condition. The condition, in this model, is the cage. Rat Park was a plywood box in a university laboratory in British Columbia. It ran for a few years, produced a handful of papers, and was then shut down for lack of funding. The rats that lived in it consumed significantly less morphine than rats that lived in metal cages. The rats that were forcibly addicted and then given a choice largely chose, in Rat Park, to stop using. Whether that finding replicates perfectly across every experimental condition is disputed. The science is not settled in the way popular accounts suggest, but the question the experiment raised has never been satisfactorily answered by the alternative model. If the drug alone causes the addiction, if the chemical is sufficient, then why did 88% of soldiers addicted to heroin in Vietnam not relapse after 3 years at home? Why did the same rats consume 20 times more morphine in a metal cage than in a colony? What was the cage doing that the drug alone was not? Those questions were raised in 1978. They are still not fully answered. The sources for everything stated in this video are in the description below. Subscribe if you want more.